Okay, so today we're going to be talking about sine, which is this graph, cosine, and tangent. Okay? Let me get rid of those. We'll add those back later. So, sine and cosine are made from, and tangent, are made from the unit circle. Let me zoom in here so you can get a better picture. The purple line is tangent, the blue line is cosine, and the green line is sine. All are made from the unit circle. Sine, which is green line, is made from the y coordinates. So, if we look here, 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 and here, you can see that you see the pi's. Each one pi is 180. So this is 90, 270, 360. Based off the unit circle, you would use the y coordinates. Sorry, you'd use the y coordinates to figure out where it would go. So 90, the sine of 90 is 1, so it goes up to 1. The sine of 180 is 0. Sine of 270 is negative 1. And the sine of 360 is 0, which is how this gets its shape. And the same story happens with cosine. Cosine is also made from the unit circle, but instead of using the y-axis, you use the x-axis, which are the x coordinates, my bad. So at 0, the x coordinate is 1. So up here, you got 1. At pi over 2 or 90, the x coordinate is 0 because the unit circle only has a radius of 1. So at 90 degrees, or going straight up the y-axis, would be 0. The x-coordinate of 180 would be negative 1. The x-coordinate of 270 would be 0. And the x-coordinate of 360 would be 1. And as you can see, these just keep going on forever because it's a circle. And thus, you would have these oscillating patterns. I think oscillating is the right word, or repeating patterns. So as you can see on the sine graph, you go middle up, middle down, middle, and on the cosine graph, you start up, middle, down, middle, up. So you start and end on the middle line for sine, and you start and end on the top line for cosine. Tangent, which is this line, or these graphs, is the result of putting sine over cosine or y over x. And what they do is they also go on forever. Okay? And each one is just an interval of pi away, or 180 away. And as you see, it starts at the bottom, works its way up, curves the other way, and goes up. And so each one does. And that is the result of cosine over sine. Or sine over cosine, excuse me. Cosine over sine, or x over y, is cotangent, which, as you see, is also an interval of pi away. But if you look, it's the opposite of tangent, which means it's 1 over tangent, or cosine over sine. And that starts up, down, curves, curves, down. So up, curve, down. And that is the result of cotangent or cosine over sine. Now we're going to talk about secant and cosecant. So first we're going to start with cosecant. If you look at your sine graph, you see you have these waves and crests, or crests and troughs, my bad. If you do cosecant, which is 1 over sine, you get these orange graph. So these parabola looking shapes. Parabola. And pretty much all you do is you flip your sine graph and extend the lines. See how it's on every top and bottom? So that's pretty much what they look like. And the same is true for cosine and secant. Secant is 1 over cosine. So again, you're pretty much just taking your tops and bottoms and flipping them and setting lines, and these two go on forever because again, unit circle. Okay. So that's how those are made. Now, we're going to talk about, whoops, we need this to be minus pi over 2. We are going to talk about amplitude, phase shift, horizontal shift, and period. So, this is our normal sine graph. This is a sine graph with all of those things incorporated. This 2 here is your amplitude. You use this 2 here to find your your period, sorry. You use this to find your phase shift and this to find your horizontal shift. So, this is assuming that you have a amplitude of 1, which is why it only goes up to 1. See? Up 1, down 1, up 1, down 1. So this 2 makes it go up 2, down 2. Up 2, down 2, up 2, down 2. You get the drift. And this 2, right here, well, without that 2, your middle line of your graph would be 0. So, when you do that plus 2, whoop, wrong one, plus 2, it moves it up 2, which makes the middle line of your graph 2. And you use this 2 to find your period, and the period is found by 2 pi over 2 in this case, but usually it's 2 pi over k, and usually k is this number. Now, without this number, it's pretty much the same deal. It doesn't look it, but it's pretty much the same deal as your normal sine. Now let's look at it if it was, so this is 2, it's scrunched, like each wave is smaller, but if we go 1 over 2, you see that your wave is much larger. So, let's bring our 2 back. This number is the phase shift, or this fraction. If we got rid of that, whoops, x, it's pretty much the same thing, except it's scrunched. So you start at 0, up, pi over 4, 3 pi over 4, and you get pi here, which is what our period was, is pi, right? Up, down, middle. But because of that phase shift, we move over pi over 2 or half pi. So let's bring that back, pi over 2. Whoops, hold on. Minus. There we go. So, see? You go up. Here's pi over 2. There's pi. So that is one interval. We just move over. And the same thing happens again for our friend cosine. I have the spinning wheel of death. Here we go. So here's our friend cosine. Again, we have that 2 cosine of 2x minus pi over 2 plus 2. And again, we just applied the phase shift of pi over 2. Because this part is usually at pi, but because of our interval of, or our phase shift of pi over 2, we moved over pi over 2. And this is usually at 0, but because we moved over pi over 2, it's now over here. Now, and again we have this 2, which makes our graph smaller. And this 2 brings our graph up. And this 2 makes our graph taller. Or this 2 makes our graph taller, yeah. And if we look at secant, or cosecant and secant, again, oh wait, yeah, get rid of cosine. You can see that the same thing happens again. You're just combining, you're just pretty much putting parabolas at the tops and bottoms of your graph, which is what happens for cosine and secant. Now we're going to talk about tangent and cotangent. So, zoom in here. So, we have, oops, that's cotangent. We have 2 tangent of 2x minus pi over 2 plus 2. And it's pretty much the same game as the others. This is the amplitude, which is making our graph stretch. This is our period, and as you can see, we are now having a smaller period. Right? It's no longer pi. Now pi over 2. And we have this phase shift of pi over 2. So we moved everything over pi over 2. And we have this plus 2, which does that. It moves our center of the graph up to 2 plus 2. See? There's the center. Right here. Can't exactly get to. And the same game happens with cotangent. Cotangent is, of course, the opposite of tangent, or the reciprocal, 1 over tangent. And it's pretty much just doing the opposite of what tangent does. It starts up and moves down. Now I'm about to make you go crazy by adding in everything one at a time. Sine, cosine, sine, cosecant, cosine, secant, tangent, cotangent, 2 sine of 2x, 2 cosine of 2x, 2 cosecant of 2x, 2 secant of 2x, 2 tangent of 2x, and 2 cotangent of 2x.